Dear students, in our last class we discussed about the empirical formula and we came to know that how we can calculate the empirical formula from the given percentage. Today we'll learn about molecular formula. Molecular formula of a compound denotes the actual number of atoms of different elements present in one molecule of the compound. That means, say for example, the molecular formula of hydrogen peroxide is H2O2 and that of glucose is C6H12O6. That means in hydrogen peroxide the total number of hydrogen is 2 and oxygen is 2. Similarly in glucose, carbon is 6, hydrogen is 12 and O is 16. Now we need to know the relation between empirical and molecular formula. So molecular formula equals to n into empirical formula, where n is an integer which starts from 1 to 3 dot dot it goes on, and n can be found by the formula molecular mass. N can be found by the formula molecular mass divided by empirical formula mass. Molecular mass we know how to calculate from the given compound, and empirical formula mass we have came to know from our previous class. Now numericals based on it. Say for example, calculate the empirical formula of a compound whose molecular formula C8H6O4 and empirical formula weight is 83 is given. How we can do it this thing? Molecular weight of this first we need to calculate by using the formula. Then we have got this n into empirical formula equals to molecular formula from the above relation. Then from here n is molecular mass by empirical formula mass, so which will come as 2. Now again we will use the same formula, molecular formula equals to n into empirical formula. So molecular formula we have got in the question and the value of n we found, so we need to find the empirical formula. So this 2 will go and divide the molecular formula, so it will become half of the number of atoms, C4, H3 and O2. Now that is just for the calculation of empirical formula. Now the important thing is this one. Example 2. An organic compound has the percentage composition of carbon 40%, hydrogen 6.7% and oxygen 53.3%. Find the empirical formula of the given compound first, and its molecular formula is 60. So find the molecular formula of the compound. So finding of empirical formula from the given organic compound we have done in our previous class. So after that we have got the addition, calculation of molecular mass. So for this again we'll do in a similar way. We'll first make a table, and in the first column we'll write down the name of the element. In the second we'll write down its percentage composition that is given. Then we'll write in the third atomic masses. Then atomic ratio can be found by dividing percentage composition by its atomic mass. So you'll get these values. Now to get the simplest ratio out of this you have to select the lowest number. So lowest number is 3.3. So we'll divide all this number by lowest number. So the first ratio will come as 1, 2 and 1. So these are the number of atoms present in that molecule of a compound. So the empirical formula of the compound will become CH2O, 1 carbon, 2 hydrogen and 1 oxygen. So for this now we need to calculate molecular formula. So for that we have got the formula molecular formula equals to n into empirical formula. So first we'll find empirical formula mass. So from this formula which will come as 30. Now we'll find the value of n, molecular mass by empirical. Molecular mass is given in the question, it is 60, and empirical formula mass just we found out 30, so it will come as 2. Now we'll use the formula molecular formula equals to n into empirical formula. Empirical formula we have found over here, and the value of n also we found it 2. So we'll just put it and we multiply this 2 by this empirical formula, it will become C2H4O2. So this is how we can calculate the empirical and molecular formula. In a similar way I have given you 2 problems, so follow these tips systematic and do this 2 numerical and send to my email. Thank you.